Welcome back to The Explainer. If you've been following along with us, you've absolutely mastered the building blocks. We're talking containers, images, Docker files, volumes, networks, the whole shebang. But now it's time to take all of that theoretical knowledge and actually see how it operates out in the wild. Okay, let's dive into this, because today we're shifting gears from basic Docker concepts straight into real-world DevOps environments. We're going to look at exactly how organizations deliver software faster and way more reliably than ever before, all by tapping into the sheer power of automation. Here's our roadmap for today to connect all these dots. First, the need for speed. Second, the CI/CD pipeline. Third, orchestration with Kubernetes. Fourth, Docker best practices. And finally, number 5, the big picture. All right, kicking things off with section 1, the need for speed, moving fast without breaking things. So the reality of modern software development is that companies aren't just releasing software once a year or even once a month anymore. They're releasing new features all the time, sometimes multiple times in a single day. And they have to pull this off while demanding absolute 100% reliability. To achieve that kind of insane speed without the whole system just crashing down, organizations rely heavily on CI/CD pipelines. Think of this as the foundation of your automated software factory. Let's break that acronym down really quick. CI stands for continuous integration. This just means developers are frequently merging their code changes into a shared repository, and every single time they do that, the code is automatically tested. CD stands for continuous deployment, meaning that once those tests pass, boom, the applications are automatically deployed. No human bottlenecks whatsoever. And this brilliantly illustrates exactly why Docker is the absolute hero of the CI/CD story. Look, before Docker, we had a massive problem in the industry. Environments were totally different. An application would work perfectly fine on a developer's laptop, but the absolute second it was pushed to production, it crashed. With Docker, that dreaded, well, it worked on my machine headache is permanently cured. By packing the application inside a container, Docker creates perfectly identical environments everywhere, guaranteeing absolute consistency. Moving right along to section 2, the CI/CD pipeline, the journey of code. Let's actually track a single piece of code as it moves through this automated deployment assembly line. Just imagine a developer finishes writing some code on their local machine. Here's the journey. Step 1, that code gets pushed to a source control system like Git. Step 2, a CI/CD tool immediately spots that change and automatically builds and tests the application. Step 3, once it gets the green light, a Docker image is created and pushed straight to a Docker registry. Step 4, your deployment servers automatically pull that brand new, fully tested image. And finally, step 5, the new containers start automatically. Just like that, the updated application is live for your users. And the craziest part? This entire highly complex process happens without a single human clicking a button, making deployments infinitely faster and way safer. Now, you might be wondering what tools actually manage that automated journey for us. Well, there are a few heavy hitters dominating the industry right now. A lot of organizations use Jenkins for their automation. Others really lean on GitHub Actions, GitLab CI/CD, Azure DevOps, or Circle CI. And the true beauty of all these tools, they integrate seamlessly with Docker. Whenever new code is pushed, the pipeline just uses Docker to automatically build and deploy those containers, drastically cutting down the chance of any human error. Let's quickly revisit that idea of consistency across the entire pipeline. A typical company is going to have multiple environment stages, right? You've got development, testing, staging, and then finally production. Without Docker, trying to keep your software versions consistent across all those different stages is basically a nightmare waiting to happen. But the Docker solution? You just take the exact same image and use it across every single environment. What you tested in the testing stage is exactly, byte for byte, what goes into production. It massively reduces your deployment risks. All right, let's jump to section 3, orchestration with Kubernetes, scaling up. Up until now, we've really just talked about getting a single container updated and deployed. But let's zoom out for a second and look at the massive scale of an enterprise fleet. Running a few containers on your laptop, that's easy. But when you have large applications that require hundreds or even thousands of containers running at the exact same time, managing all of that manually is completely impossible. You need a robust system. You need an orchestrator. And this is exactly where Kubernetes enters the picture. Kubernetes is the most popular orchestration platform in the world right now. You can think of Docker as the factory that actually builds the containers, and Kubernetes as the highly intelligent manager that oversees all of them. Kubernetes automatically manages your containers at scale. If a container randomly crashes, Kubernetes instantly detects it and spins up a replacement.
If your app gets a sudden, massive spike in web traffic, Kubernetes automatically launches additional containers to handle the load. It essentially ensures high availability and performance across your entire system without you having to lift a finger.
Let's move on to Section 4, Docker Best Practices, Securing and Optimizing.
So, the crucial point is, because we're dealing with these massive, highly automated production environments, we absolutely have to follow some key rules to run Docker safely and efficiently. First up, keep your images small. This means they download faster and use way fewer resources. Second, use official base images whenever you can, simply because they're maintained and updated regularly by the community. Third, and this is a big one, securely manage your secrets. Never, ever hardcode passwords or API keys inside a Docker image. Use environment variables instead. Fourth, regularly update your images to get the latest security patches. And finally, use specific image versioning. Don't just slap the generic latest tag on everything. Use version 1.0, 1.1, and so on. Trust me, this makes your deployments predictable and vastly easier to troubleshoot when things go sideways.
Of course, once you have these beautifully optimized containers actually running, you can't just look away and hope for the best. Production monitoring is absolutely critical. You have to track container health, resource usage, and performance metrics around the clock. Some of the most popular solutions for this are Prometheus and Grafana. These tools give you the critical dashboards and alerts your team needs to spot and fix a problem before your users ever even notice a glitch. Finally, Section 5, the big picture, Docker in the real world.
Let's take all of these sort of abstract pipeline and orchestration concepts and ground them in a highly relatable, real-world scenario. Imagine a massive online streaming platform with millions of users watching videos every single day. Now, that platform isn't just one giant, clunky block of code. It's actually made up of multiple microservices, user authentication, video processing, recommendation engines, databases, APIs, you name it. And every single one of those services runs inside its own isolated Docker container. Kubernetes is sitting right there, orchestrating thousands of these containers across multiple servers to ensure your streams literally never buffer. Meanwhile, the CI/CD pipelines are constantly working in the background, automatically deploying updates and dropping new features without ever having to take the platform offline. This incredible combination is the secret to exactly how modern cloud-native apps operate at such a massive scale.
Docker has completely transformed software development. I mean, it makes applications portable, infinitely scalable, and just beautifully easy to deploy when you combine it with modern DevOps practices. We've covered the workflows, the automated CI/CD pipelines, Kubernetes orchestration, and all the essential best practices. But look, theory is only half the battle. Now that you truly understand how all of this operates at scale, I have to ask you, are you ready to build a complete Docker project completely from scratch and actually deploy a real application yourself? Keep this big picture fresh in your mind, because that is exactly what we are going to do next time. Stay curious,